welcome. Welcome to the ACE Mentor Program of Washington Student Presentation Night. My name is Angela Gatula. I'm the Executive Director for the ACE program here in Washington State. For 19 years in our area, the ACE Mentor Program has brought together key sectors of the design and construction industry, architecture, engineering, construction management, real estate development, and more, to raise the awareness for hundreds of high school students to the possibility of careers in these fields. Since 2001, an estimated 3,000 students have gone through our local ACE program, and we have awarded more than $764,000 in scholarships, and we plan to award 100,000 more to 14 of our seniors later this month. And several of those seniors will be featured tonight giving their presentations. Locally, about 220 students from 64 area high schools participated in this year's program, which consisted of 11 teams, 7 in Seattle, 2 on the east side, and 2 in the South Sound and Tacoma area. Our Puget Sound program ranks among one of the highest in the nation for the number of high schools that are involved. The students are being mentored by 185 of the industry's brightest professionals from 65 of our region's architecture, construction, and engineering firms. At about 4 o'clock this afternoon, I emailed a program to all of the students and parents and mentors and registrants of this event. In the program, it lists the names of all the students and the mentors, and it outlines a bit more about our student project tonight. I'd like to give a special congratulations to this year's outstanding seniors. This was a senior year unlike any other. And I also want to call out one particular senior, Marcela Tulepa, a 4-year ACE student. Marcelo did ACE for all 4 years of his high school experience. There are some years we don't have any student who's done it for all 4, but Marcelo is the one we're celebrating tonight. This is quite an accomplishment. The program I sent also has links to our Facebook and our Instagram pages. Be sure to check those out and like us and follow us if you'd like. Over the course of the year, over the course of the school year, teams met every other week. They visited construction sites, they learned about each of the disciplines, and they toured mentor offices. The team spent most of the year working on a design project in response to a mock request for proposal that ACE's leadership team created. All of the students' hard work culminates in this evening's presentations. This year, the students were challenged to redevelop one of 3 different sites along the Seattle waterfront, and I'm excited to see what the teams have come up with. So, of course, we would like to acknowledge the incredible effort of all of the mentors and the students as we worked around school closures and quarantine mandates, and we transitioned to a virtual ACE program. All 11 of this year's ACE teams finished their designs and recorded their presentations to be webcast in a series of virtual events this week. Tonight is the last of 5 ACE events. We've been celebrating ACE all week. Congratulations to everyone involved, the students, the mentors, and the families, for finishing this year so strong. So, to up the prestige a little bit for a virtual event, we invited a panel of judges to review the presentations and moderate the Q&A session tonight. I'd like to introduce our panel to you. First, Larry Schwartz is a principal at Notkin, a PS2 company, and he's a longtime member of our ACE Board of Directors. Larry has already called in to several presentations earlier this week. I know he has a solid background of this year's RFP and what the design possibilities are, so watch out for him. Second, Beatrice Arostegui is a senior design engineer at Magnus & Clemensic Associates. Beatrice has mentored for many, many years as a team mentor leader, and she personally knows the effort it takes to put these designs and presentations together. She's not participating as a mentor this year, and she agreed to join us tonight as a judge. Thank you, Beatrice. Lastly, we invited Todd Inoki. He is a vice president at Callison RTKL. Callison RTKL has been a large supporter of ACE for many years, but I believe this is the first time that Todd has attended a presentation like this. He's our invited industry professional, and I look forward to his comments. I also heard a rumor, he'll have to tell me if this is true, that he has an incoming high school student who might be interested in ACE. So tonight, it's everyone's job to show Todd what a good time we have in ACE so he can encourage his family to participate. Okay, deal? Deal. Let's do it. We wanted our panel of judges to be an interesting mix, so we invited a board of directors member, a former team leader, and someone from the industry, and I'm really excited about this group we have tonight. So thank you to the 3 judges for participating. Okay, so now you're probably wondering how this is going to work. So let me explain it to you. First, all the attendees should stay muted. We are on a Zoom webinar right now, which means most of you are attendees, but some of you are considered panelists. If you're an attendee, you can't turn on your microphone, you can't unmute yourself, you're just a viewer. But if you are a panelist, we'll be able to see your photo, or we'll be able to see your video, you'll be able to unmute yourself and you can speak. So kind of imagine that all of the students right now are panelists and we're standing up on a stage in a theater. Everyone is standing behind me, both of the team members, or the Wednesday team 1 and Wednesday team 2. They, all of the students, their name should already be on this call as their first name, their last name, and their team name. So what's going to happen is during Wednesday team 1, all of the Wednesday team 1 students will remain panelists. They will be able to show their videos, they'll be able to speak. During the Wednesday team 2 presentation, those students will become panelists. Everyone else will be attendees. If you look at the bottom of your screen, there's a button that says Q&A. So what that means is, if you click on it and you're an attendee, you can type in a question. So if we are viewing the videos and you've got a great question that you'd like to pose to the team, you can type it in right there. Only attendees can type in questions. Panelists cannot. So anyone on the call may type in a question. After the video concludes, our 3 judges will moderate our Q&A session. They can either go to the Q&A box and take some of those questions and pose it to the larger group. They could come up with their own questions and their own ideas and pose it to the group of students, but we will have a short Q&A after each presentation. So if you're an attendee, your challenge is to come up with some interesting questions and pose it to the team, and then we'll see how the students respond. After the first video concludes, all of the Wednesday team 1 students will be turned into attendees, and all of the Wednesday team students will be promoted to panelists. So that way, it will be their turn in the spotlight. We'll get to see their videos, they can respond to the questions, and then they'll be put on the spot. So, let's see. Lastly, I just wanted to say one more thing. There are 2 presentations tonight. Please remain for both presentations, even if you're only here to see a student who's presenting in the first video. This is a way that we can support each other, be respectful for everyone's time and all of the energy that they've put into this event. Okay, so before we get started, right now, Mark and I are going to go through our participants and we're going to turn our Wednesday team 2 students into attendees. So like I said, imagine we're all on a stage in front of you and now the Wednesday 2 students are going to sit down. So this is going to take a minute while we go through and do this. Okay, Mark, are you ready? I think he's ready. Here we go. The students will find that you're kind of kicked out of the meeting for like 10 seconds. It's less than that. It's like a couple of seconds. Roll to attendee. And this is the magic of technology. Okay. Let's see 1. I think we're ready to go. Okay. Our first video tonight is Wednesday Seattle Team 1. The team leader is Casey Risky with the Miller Holt Partnership. Casey, if you would like to introduce your team, just say a little something and then we'll let the video roll.
Thanks, Angela. This has been a very challenging year for all of you, as you expect. The design challenge of this project was really interesting because it actually integrated with the waterfront and how we integrate with that and how we made that all work come together. I had a really strong team this year, and they rocked through it really well. We had some that went to and participated in the Popsicle Bridge competition that happened. That was pretty fun event also. I want to give a special thanks to all the mentors and that helped pull this through. Congratulations, guys. You did a great job. Looking forward to the final presentation. Let her roll, Mark.
Hello, everyone. My name is Dylan. I'm a senior at Skyline High School, and I'm also part of the architecture team. For ACE 2020, we have been tasked with the redevelopment of the Seattle waterfront. So our solution to the task this year is our design of the manta ray. Throughout this journey, I'm proud to say that I've worked with so many amazing mentors, and we've included their companies in this slide here. And also I've met some other amazing peers from all these schools. And obviously right now we're faced with the situation to go online, and I felt like we've all handled that very well. So after we sat down as a team and looked at the RFP, we moved on to the conceptual phase of the development. We had several goals. These included, maintaining the flow from the upper Pike Place Market area and the lower waterfront, and I'll talk a bit about that in a second, as well as creating, a cultural hub for people, combining the museum, performance space, and the marketplace. And, these things were mentioned in the RFP, and we kind of, as a team, decided we wanted all of the above. So that was very fun. And we also wanted to incorporate and go above and beyond in terms of sustainable elements, creating green roofing, improving energy efficiency and water usage. So our location goes a lot into what we wanted to do with flow, right? If you go to the waterfront right now, there's this big discrepancy between the upper marketplace, the upper Pike Place marketplace, as well as the waterfront and the street below. So we wanted to increase the porosity between these two different levels and allow people to pass through freely. If we look at the site right now, in this slide, we included a picture of Miller Hall's current development, and they also did a lot of the things I previously mentioned. And on the right here, we have the current already built the upper Pike Place, a really beautiful place, and we wanted to allow people to go from that place, the upper Pike Place, to the waterfront street below.
So this is our space programming kind of diagram list. First of all, my name is Anna Huff, and I'm a junior at Roosevelt High School. And so with this space programming, we needed to kind of list out what we needed in designing our space, and that helped us kind of have a better picture of how we could incorporate our needs for the space into our design and how that would impact the design. And so these are some of our inspiration photos. Clearly our roof is similarly shaped with some curves, and it's a green roof. And we also have circular skylights on the top to let in a lot of light. Since our building is facing west towards the sun when it sets, we wanted to really utilize and kind of use the best natural light we could. So we wanted to use a lot of skylights and natural light, and also kind of use the greenery to increase efficiency, but also kind of create a beautiful green space in the middle of the city.
And then we started sketching. These are some of our initial sketches, as well as some more finalized concepts. So on the left here, if you look at these two pen sketches, they're really similar to what I talked about in terms of the location. We wanted to connect those 3 points. So that's kind of how we arrived at this form of this the manta ray, essentially, allowing people to travel and connect between those 3 points. And as we moved along, we kind of wanted to include this, beautiful upper roofing area in the middle of these 3 points, and also include windows that would allow people passing by to get a sneak peek into our museum, into our performance space. And then we started looking at what we wanted to do in terms of the landscape and the roofing, and inspired by what Anna was talking about earlier with the images we found.
I'm Skylar, and I'm a junior at Roosevelt High School. And here we have the floor plan, the main floor plan. So on the first floor, we have the performance hall, which is located on the left side of our building. And to enter into the performance hall, visitors have to pass through the marketplace, which is designed to house a variety of vendors. And then when visitors enter into the building from the main doors, they encounter the information desk in front of them. And to the left of the information desk is the museum exhibit, and behind the information desk is where the bathrooms are located. The elevators and stairs are also located next to the information desk. On the second floor, we have the restaurant with access to the balcony and the bar area. The kitchen for the restaurant is located in the top left corner of the second floor. The general seating area for the restaurant is highlighted in dark blue. The bar area is highlighted in magenta and is located on the far right corner of the second floor. The elevator and the stairs are also located next to the bar area.
So I'm Keith from O'Day High School. I'm a sophomore. Right now we're looking at the roof plan of the exterior of the building. At the center you see a circle that is like all the skylights and where the people will be walking from our grand stair concept. From the bottom up you see kind of a U shape that heads up into the circles, and it continues up onto Front Street. These little like honeycomb looking things around the front and right side, those are solar panels that we can use to harness energy for our building. Moving on to the side view, we get a better look of how this is all held up and how the stairs work. This is from the right side of the building, and you can really see the depth of the stairway on the left side and how it comes up onto this spherical skylight panel. It kind of breaks up a grouping of those solar panels, as I mentioned. And you can see all the columns headed back up the tail, we like to call it, of the man array that are providing support for the stairway that you can kind of see peeking up at the top, right at that top like dashed line, which is the market level. On this diagram, you can see all three levels: the ground level, the upper level, and the market level. Those are symbolized by the three horizontal lines through the diagram. After this, we can see the front view. You can see in the background, these are all the buildings around it, and you can kind of see how it starts to fit in with its surroundings. We have a massive front window panel, and you can really see the curvature of this building's design through this front view, which I find really cool. You can also see that we have the columns coming down from the curve to the floor for support, as well as you really can see how the stairs look from this. This is like if you were in the water from where this viewpoint is taken. Next, we get like if you were actually on the ground standing next to it. This is where you get a very clear view of how the stairs will like angle up, as well as what the building would look like to you if you were walking towards it. This also, yes, the ground view from the other side, you can see the lip or like eyelid of the building, which is really cool. They're tinted windows, so they'll provide shade for the viewers. In the front window panel, you see how there's clear windows and there's some that are like grayed out. Those are like semi-transparent solar panels. And since our building is facing west, it'll capture a lot of light and actually provide even more energy capabilities for our building. Now this is the full ground view. This is like if you were even farther off to the right of the building, this is like where you get the best view of how our stairs would go up into our solar panel area. We spent a lot of time talking about these stairs, and that's just because that's where people are going to be walking a lot of the time to get up to the market and down from the market from here. This is where you get a really clear view of the angles of how it would be taking. The elevated front view is really cool because you really get to see how this sizes up. We have a really wide doorway, which will allow more people to go through more easily and make everything less kind of crowded. Again, you can see how the angles of the solar panels, the front ones and the ones on the roof, will be able to like collect electricity. And you do get a peek of the interior from here. Speaking of.
Okay, so this is our side cross section, and it's kind of sliced from the left side, and so you can see into our interior. And in the middle, you see our stairway going up to the second floor where we have a restaurant and bar, and the elevator shaft right next to it. And then on the left, we have our theater area. You can see the stage is kind of at the bottom left where the floor is sloping down to it. And then on our right, there are the windows and those solar panels, and then you can see the green roof and how the stairs come down from the Pike Place Marketplace to our roof and our solar panel circle and the viewing section for our skylights. And then we have the front cross section where you can see kind of we slice the building down the front, and here you can still see the elevator shaft and the stairs, but you get a better look at the museum and how the that kind of U shape in it creates more space for specific exhibits. And then there's on the left there are spaces for the marketplace around our theater, and you can see there's big space, and there's the doorways that welcome visitors into our theater space. And then next we have the cross section from, this is again from the left side, but it's more extreme. So we're looking at the building from the left side, sliced down the middle, and you can see the stairs again, the elevator shaft, but then you see kind of better how the museum is laid out on that right side of the building, but then also how the roof kind of comes over and shapes that space.
Hi, my name is Braden Tarago. I'm a junior at Roosevelt High School, and I'm also part of the architecture team. So here we have another cross-section of the side of the building. In this cross-section, you can see most of the stairwells along with the elevator shaft. So we wanted to ensure accessibility to all of the different parts of the building. So we have both large stairwells, as you can see in the center there, as well as an elevator. And in addition to these things, you can also see various parts of the building, such as the theater in the bottom left and some other parts of the building on the right side. And in addition, you can also see some aspects of the foundations that gives you kind of a better idea of how our building stands up. And then here we have a view of the interior main stairway in the building. So along the right, you can see some pictures of what we were envisioning our stairway to look like. So not only do we want to ensure that the stairway was aesthetically pleasing, we wanted to make sure that it was functional. If we're having a high volume of people moving throughout this building, we want to make sure that the stairways are big and that they work and that everybody can get from point A to point B without problems.
My name is Elise Lesniak. I'm a sophomore at Archbishop Murphy High School. This is a view of the marketplace. It is a wide space for many people to access and enjoy. This will provide a seamless transition into the existing Pike Place Market. This is the main entrance. This view is seen right as you walk into the building. This is the view of the north. The reception desk will be located under the stairs, and the marketplace can be accessed to the left. This is the view of the stairway going up to the second floor of the building. This leads up to the beautiful dining space where people can enjoy the view of the waterfront.
In this view, we can see the stairs that come up from the main floor of the building. Behind the stairs is the seating area for the diners, and this space was designed so that all of the diners could enjoy the views of the water from their tables. And our furnished seating area would look like something similar to the pictures you see above. This is the upper level view of the museum space in our building, and our exhibit space is spacious and it's designed so that it can accommodate a variety of pieces. And the bar area, located on the same floor as the restaurant, has an indoor balcony feel to it since it has a full view of the museum exhibit on the main floor.
So here we have a ground level view of our museum area. So with our museum area, we wanted to seem very natural and make it really easy for people to walk throughout the museum while still making it easy for them to leave if they want, because you can get really tired and if you're walking through a museum a lot. And we also wanted to use lots of curvature in the design to make it seem very modern and just overall cool. So here we have a view of the marketplace from overhead. With this view, we wanted to give a nice view from above so that people can look down on the marketplace. They can get a nice view of the layout of the market and of the options that they can choose from.
Hello, my name is Pedro Cruz, and I am a junior at Highline High School. And what I am working on is a restaurant. So for our main idea for the location of the restaurant, we decided to place it on the second floor because it would give visitors and staff a view of the waterfront, which would animate the interior atmosphere and add to our concept of representing the marine life. Okay, so as you can see on the left picture, we had an idea of enforcing the skylight into the main dining area. It gives you a big view of the west, and for our ceiling, we decided to bring that idea of the museum covered walls pattern to the restaurants, to the ceiling, as it extends the aesthetics of the flowing water and life within it. In terms of seating allocation, the ability for chairs to be moved and open plan allows a spacious area where customers and staff can freely walk through open space without clustering. For the balcony, we decided to add more comfortable cushion seating. Customers who wish to come here are able to exit the main seating area and step onto a small pathway where pairs of 2 chairs are distributed in both sides of the balcony. And this would ultimately be expected to be occupied during hot or humid days.
So here we have a picture of the seating in the theater. With the theater, we wanted to give it a nice and open feel with lots of comfortable seating for everybody who wants to be there. Obviously, if we're going to have a lot of people in there, we need to make sure that these people are well accommodated. So we have some nice seating. And the theater is obviously a really large part of our building, so we wanted to spend a lot of time on it and make it look nice. So here we have a really brief mock-up of what the acoustics in the theater could look like. We try to really precisely calculate these angles to ensure optimum sound quality and retention so that all of our guests can hear really well, can hear what's happening up on the stage and stuff like that. Because if there are going to be important performances and presentations that are happening in this theater, it's really important that we prioritize the sound and make sure that everybody from the front row all the way to the back can hear what's happening up on the stage. So here we've got some examples of what the exterior of the building could look like. We obviously want to have some big, nice glass windows to make sure that lots of light can get into the building and that's well lit. We also wanted to use some concrete to make kind of a more natural and even maybe a little bit of a rough feel to kind of make sure it blends in. And we also wanted to use some steel to make sure that the building not only looks good, but it is also tough. And even further, we're using a green roof up on the top of the building so we can kind of make our building seem even more natural. And then here are some examples of what the interior of our building could look like. We want to utilize a variety of materials to create a really welcoming environment. So you can see we want to use lots of wood to make the building seem really natural. Wood's a classic building material, so we're going to use a lot of that in there. We also wanted to use lots of glass and steel, like I mentioned before. And our floors are going to be pretty standard, kind of like a polished concrete to make a more relaxed and natural feel so people kind of feel at ease in the building. And we want to kind of aim for, again, a really natural feel, like you can see up here on the top right of the slide.
So with our rooftop landscaping, we wanted to focus on native plants because that is really important to kind of encourage those habitats and continue to maintain habitats for creatures in the city with these native plants. So some of the native plants include different types of ferns, like Pacific oak fern or the spreading wood fern. There's the red flowering currant, which is the pink flower you see. Mock orange is a white flowered bush in the bottom left. And grasses, there's certain grasses are native to this area that would be very helpful for green roofs. On the right, we have some certain kind of concept ideas for different rooftop green roof ideas, and we want to have kind of variety in our plants, but also have have a focus on native plants to kind of tie back to this area, and also incorporate the benefits that native plants bring to green roofs in this area. And then also for the rooftop, we wanted to, create a more biodiverse rooftop and green roof. So by doing that, we could help the pollinators of our city by including things like lavender and these purple and white flowers on the left, and then those will kind of help biodiversity help spread in the city and create more habitats for our pollinators, which are very important to our ecosystem. As well, ground covers are really important for green roofs. They often, like sedum, often don't need a lot of water, but they also create that green roof and create other plants that capture carbon. That's very important for our efficiency of our green roof. And then again, we wanted to kind of, one of our creative our creative elements was to have on top of our green roof garden, a garden for the restaurant, and to tie those elements of our building together. We would only be able to use things like thyme, rosemary, spinach, oregano, chives, those kinds of things, because though their roots are shallower with the dirt we have, because otherwise if you have really plants that need a lot of soil, our roof gets heavier and it's harder to support. So we had probably here are our design ideas for how we lay out those gardens, but we wanted to help support our restaurant with the space we have available on our green roof. And finally, so our team has gone through the LEED scoring and guidelines. We were pretty, we had to kind of guess on what we would do for certain processes, but we thought we might be able to do platinum, which is definitely a reach, but we thought with our building and with the space we have available for a green roof and the solar panels on our roof, especially with our building facing west, to kind of maximize and optimize that light and that energy, our building we think would get LEED and LEED Platinum certified. So that was an important aspect of our design, to try and keep that in mind and keep that energy efficiency and space efficiency in mind.
Hello, my name is Jonathan Unruh. I'm a sophomore at O'Day, and I'm the Structural and Geotechnical Student Design Engineer. In collaboration with mentors from KPFF and Shannon Wilson, I will be presenting on steel and concrete composite structure, site characterization, and shallow foundation design. We began our design looking at design loads such as dead loads, otherwise recognized as inherent permanent loads, prescribed for the structural code ASCE 710 in retail, assembly, and upstairs and stair spaces. We also looked at live loads, otherwise known as variable loads, such as humans, animals, and furniture that we might expect inside the structure or outside on the rooftop park. Then 47. Once we determined the loading criteria for a structure, we began framing. This included identifying locations of gravity elements, like concrete columns, steel girders, and steel beams, identifying the lighter elements such as location of the concrete core and steel braced frames, and finally identifying the foundation system using shallow concrete footings. Our next step was to determine loads to design a typical beam. We did this by determining beam spacing and using tributary width to calculate shear and moment. Using these worst case loads, we designed a typical beam using the steel construction manual. The reason the beam is 95 feet is that it goes over an auditorium and a column would block the view of the people inside. Some of the main reasons we use reinforced concrete columns are that they are fire resistant, aesthetically pleasing, and strong in compression. Our next step was determine loads to design a typical interior column. We did this by determining column spacing and using tributary area to calculate the axial load. Using these worst case loads, we designed a typical interior column. Using the concrete design manual, we chose to design an interior column due to its tributary area. Explicit concrete design is beyond the scope of ACE, so we decided to do a simplified version because there are two different materials involved in reinforced concrete and it exhibits complex behavior. Our next step was to determine loads to design a typical interior column. Next one. For lateral systems, we decided on a combination of core wall and braced frames. The braced frames are located on the back and sides of the building to not block the front view, and to aid the core wall to resist wind and seismic forces. Braced frames are made up of two columns and a beam with additional diagonal members. Core walls are large concrete walls in the cores of buildings that go to the height of the building in most cases. Finally, we looked at the substructure, starting with site characterization. Site characterization involves figuring out what type of soil your building is on, then estimating the strength properties of the soil. To prevent building on stable ground that may shift or sink, on the right there's a slide of the soil types, which is called a superficial geology map. Around Seattle, by looking at the location of our building on the soil map, we decided that it was on KPON, KPOGT, and KPOG, which are made up of sand and clay. We also looked at the groundwater conditions and found that our soil was saturated. And the reason we had to do that is because water will affect the strength of your soil. And now that we know what types of soil our building is on, we can calculate the bearing capacity and settlement. We changed the shape and size of the footing until our bearing capacity was larger than our column load. We then looked at both the circular and rectangular foundation and calculated the bearing capacity of both of them so that if there were any spatial restraints, we could use the one that fits it best.
So now we will move on to the mechanical and electrical portion of this presentation. My name is Lucas Greer, and our MEP team consists of Alexandra Bourdais-Helfrich, Anthony Cabrera, Lee Connor, myself, Vincent Kwok, Max Nepialski, and Lily Nordyke. We'll first go over the electrical portion of our building and share our electrical load calculations, one-line diagrams, electrical room layouts, lighting design, power design, and solar panels. To calculate the total electrical load our building would require, we use the space-by-space method. This categorizes the typical watts per square footage for different types of spaces. This can be seen in the two tables, with Table 1 dealing with the electrical power load, while Table 2 deals with the electrical lighting load. So for example, in Table 1, we can see that an office space will typically have a power load of 6 watts per square footage. When we multiply that by the square footage of a space, we get the total electrical power load. By using the square footage of the different spaces in our building, which were provided by the architects, in conjunction with the two tables, we came up with a total building approximate electrical load of 953 kilowatts.
This is our one-line diagram, which shows that we have a main switchboard which receives power from both public utility and solar panels on the roof in front of the building. And the power from those goes into 4 480V panels, 2 on the first floor, 2 on the second floor, which have transformers between them, and 4 208V panels.
For the 2 electrical rooms, we designed and laid out the equipment needed to power the building.
we referred to the code found in the National Electric Codebook to lay out the panel boards and switchboards accordingly to meet all the safety requirements, which means having no equipment that will block the passageways. We will have a bigger electrical room located on the ground floor to service the ground floor spaces, and a smaller electrical room on the upper floor to service the upper floor spaces.
This is the lighting design of one half of the ground level. On the stage we have a mixture of XO7, XO8, XO9s, and XO6s as shown to the right of the plan. And we also have X11 linears on the acoustic panels within the performance hall. To light up the rows between the seats, we have X10s, as also shown on the left. And in the main marketplace just outside, we have XO5s. Half of those XO5s are emergency. As shown previously, we have XO5s spread out through the main marketplace, as well as a little ring of XO4s. Moving on to the museum, we have an XO3 and an XO2 in the middle of it, as well as XO1s along all of the walls of the museum.
Meanwhile, on the upper level, we have two different kinds of lighting fixtures. In our dining area, we have exposed incandescent lights hanging from the ceiling, seen in the bottom image, which are inviting and modern. In our bar area, we have cone-shaped lights seen in the top image, which provide a dimmer atmosphere for the space.
When designing the lighting, we also needed to include lighting controls. We included a lighting control panel with an integrated time clock, line switches, and dimmer switches. We included two types of occupancy sensors, which turn on when people are occupying the space. The occupancy sensor switch is used in smaller spaces and is wall-mounted, while the occupancy sensor is used in larger spaces and is ceiling-mounted. Finally, we used photocell sensors, which sense the amount of sunlight and automatically change the lighting output accordingly. When creating the power design for the kitchen, we included electrical connections for the ovens, stoves, and dishwasher. These are large equipment that take up a lot of load, about 1200 to 1500 volt amps each. The refrigerators and freezers will be powered via a receptacle with a dedicated circuit for each. There are convenience outlets on the side of the kitchen. We will have a few ground fault current interrupter receptacles in the kitchen space. GFCI receptacles have an internal breaker in them that trips when it senses a ground fault. These are usually found near sinks or where there is water nearby.
This is the plan for the solar panels on the building, with the conventional solar photovoltaic panels on the rooftop, as well as partially transparent solar panels in the front upper half of the building along the big glass entrance. And finally, with fully transparent solar panels to replace all of the other windows of the building.
Next, we will go over mechanical. The topics that we are going to go over are heat load calculations, outside air calculations, mechanical plumbing room layouts, and duct design. Heat load calculations tell us how much the building needs to be heated or cooled in the worst case scenarios and help us size our equipment properly. It takes into account geographic locations, building materials, geometry, equipment, and people. Listed above are the required airflows for cooling the building in the middle of summer.
Our outside air calculations tell us how much fresh air to introduce into the building depending on space usage and room size. So for example, in a zone such as our theater seating, we are going to have a higher outdoor air intake flow to compensate for the density of people. We also decided to size up our outside air to get extra lead points.
When selecting equipment, the theater system was designed separate from the main building according to acoustic demands. The seating is cooled separately from the stage, and extra air conditioning is provided for the backstage area. The broken up units help keep noise levels down. The main building uses a dedicated outdoor air system, DOAS unit, to supply conditioned outside air.
The remaining units were sized by subtracting the DOAS load from the total heat load and are broken up by level. We also included a kitchen exhaust fan, central exhaust fan, and variable air volume boxes for additional comfort controls.
The main mechanical room holds the DOAS, the air handling unit, plumbing equipment such as boilers and chillers for water, and a connection to the outside via the louver. There's also a shaft, seen next to the elevator, to bring fresh air from the DOAS to the upper floor. This room is conditioned by a dedicated fan coil unit. The supply duct from our main mechanical electrical room is represented by the blue lines that feed into the supply diffusers in an exposed ductwork setting. The return is a large plenum located adjacent to the mechanical room. For the performance hall, we have supply diffusers located on the floor at the back of the hall, pushing cold air forward towards the stage and up where it gets returned into a plenum. 2 air handling units cool the audience, seen in the 2 right sections of seating, and are spaced apart to minimize noise. They receive fresh air from 2 louvers. Also, the stage is cooled separately by a fan coil unit with open return to handle the high heat load space.
Hello everybody, my name is Handrea Henthorn and I'm a senior at Roosevelt High School. Today I'll be talking about construction with you guys. So this is our construction schedule. This is called a Gantt chart. So I'll be going through the few phases that we went through for our design. First we have phases 1 and 2. First phase is project design, which went through October of 2019 to May 2020. For this, we were really focusing on our conceptual design, our design development, our documents, and our schematic schedule. For pre-construction, we were working on this from March 2020 to November of 2020. Here we did a lot of things like our site logistics, prefabrication, our procedure, our procedure permits, things like that. Phases 3 through 5 include core and shell, tenant improvement, and closeout. We did core and shell through July 2020 to June 2021. In core and shell, this is where we work on the outer layer of our building. So we do this in order to make sure we have a waterproof building so that we can work on things in the inside for when there are times when there's not so great weather outside. So we focus on things like our roofing, our superstructure, our foundations, things like that. For phase 4, we had this go through July 2021 through November of 2022. This is our tenant improvement. So our tenant needs to go through a list of things to make sure we have everything on track and we have all the things that we need done. So we go through stuff like landscaping, marketplace, our balcony, performance hall. These are the different places in our building where we need to go through and make sure everything's done. In phase 5, this goes through December 2022 through January 2023. This is where our owner takes occupancy when the contractor leaves. So when everything's done, our owner takes occupancy and our contractor leaves. Our construction logistics. So as you can see here, there are many different shapes that identify some different things. Our small squares are our office buildings where we have our workers participating in. Our big circle in the middle is our crane, and we have our roads, our blue and red roads, to bring supplies and things in to construct our buildings. We also have a big rectangle in the water to bring more supplies through ships. So the great thing is that, as you can see, the circle can reach into the water to take stuff out from ships, but also have stuff on trucks, so then we don't occupy the road so much. This is our construction estimate. So we used our model to extract information to estimate costs. We did a unit takeoff and assigned a certain amount to a unit, and then calculated rough estimates on the total cost. So this is an example for structure. For example, for our foundations and piles, we had a specific unit, we had a quantity, and we had a cost. And then we use those numbers to figure out the cost based on our unit and our quantity. This is our construction estimate, so our total summary. So all in all, our structure costs about $12.5 million, our ground level $19.2 million, upper level $6.3 million, other stuff $2.2 million. For our GGCs, $2.8 million, traffic control for allowance to know how to control our traffic, $1.2 million, general requirements, so our allowance, $2.2 million, existing conditions, $2 million, and contingency, which is extra money to make sure that if anything else happens, something new, like something in the road happens, like we dig up something and we need extra money, we have that amount set aside. So our estimated total is about $52.5 million. Any questions?
Okay, thank you, Wednesday Team 1. Great job. Awesome. I'd like to see it built. I think a manta ray on the waterfront would be really fun. I would like to give our judges an opportunity to ask some questions. So Larry and Beatrice and Todd, take it away.
Great. I mean, I can go first. Absolutely. There were some pretty good questions that were actually posted on the Q&A board, and quite honestly, you know, before we get started on those questions, when you do such a daring roof and form and what have you, you're setting yourself up for some pretty good questions. So this is going to be very interesting. You know, Angela, if you don't mind, I think someone had a question with regards to the safety of the roof, and I was wondering if someone from the team could actually answer that question. And to be specific, it was how are you going to ensure that people, children, are going to be safe on the green roof? There seems to be no fencing.
I can answer that. I'm Anna, by the way. I'm a junior at Roosevelt, and so we didn't like put this into the model, but we intended like the sidewalks and the stairs to be kind of like raised up from like not at the same level of the roof. They would be kind of raised up slightly, and also have either just kind of like a glass kind of like fence or wall along those walkways. We didn't model that in because we didn't really have time, but that's what our intentions were. So we were trying to think about safety, and because that is definitely would be a consideration in if you were going to really build this. So yeah.
Great. There was another question with regards to the glass overhang, with regards to the front window in front of the window, is whether or not it was to create curvature for the roof, or what was the general intent of that clear glass structure at the roof?
I can answer that. My name's Braden. I'm a junior at Roosevelt. So I think that with kind of the overhang, it was kind of a multifaceted approach. For one, we kind of wanted to add like the curvature, since it's right on the water. We wanted to give it a little bit of shade for the building. And in addition, it was just kind of to go with the curvature of the rest of the roof to kind of like add a little bit of depth to the rest of the building. So it was just kind of there and ended up there. So yeah.
Excellent. I just wanted to share with you, you know, some of the thoughts as I was going through the presentation. I wrote down a couple of notes, and you know, there were some really thoughtful considerations to a lot of different things. And you know, as I'd mentioned, the roof form is extremely daring and quite frankly, you know, quite beautiful. The things that I liked about it, and these are really odd because they're really detail oriented, but things like considerations with regards to landscape and pollinators, and you know, I thought that was really thoughtful. And you know, just the sort of the creativity on supplying the construction from water as opposed to just all by land, I thought that was really, really cool. You know, there were some interesting suggestions that if I may, as you were going through some of the beginning stages of just the design and showing imagery, you know, just some of those imageries were quite beautiful, and to model your design after those would be fantastic, and you can really get a sense as to what you're really after. There were some imagery though that were a little, I can see why you're picking those, but they weren't necessarily, I would say something that you might want to maybe just take the time to really make sure that every single image is powerful and gets to the idea that you're looking for. So, but other than that, I did have one general question, and it was more for, I think, mechanical as well as structural and architecture, which is, with a roof form like that, the air handling units, how was the air handling units in mechanical? Typically it's on a roof of a building, and you don't want that on clearly on this roof because it's so gracious. How are we handling that in terms of getting air in and out of the building?
Hi, my name is Lily. I can answer this question. So yes, we did not want anything on the roof for this project, especially because it's such a focal point of this building. So we decided to have many units within the building. So we had to use a larger mechanical room on the first floor. And then for we had to break up a lot of the units elsewhere in the building to hide them from the public so they wouldn't be on the roof.
Thank you. Leave time for Beatrice.
Hi, everyone. I had a couple questions. One was for the architecture team. Where did the inspiration for the manta ray come? Did you first lay out the building and then say, oh, that looks like a manta ray? Or did you intentionally design it to look like a manta ray?
I can get this question. Initially, we had like a lot of different like activities as to like how to brainstorm our initial concept, and we looked at like we shown in the presentation, we kind of laid out the context as well as the RFP, and then and then we said, how do we connect these three like points for in terms of flow and stuff, and then as we started talking about it, we kind of jokingly like thought of, oh, it's kind of like this shape we're thinking about. It's like kind of like a triangle, and then it also has some elevation gain to it. So we just kind of like through our conversations, we arrived at the animal of a manta ray, because it's one of like the only things, if you think about it, that has those 3 points. And then once we got there, we realized, okay, we hit something, and then it's not just so much as a joke anymore, and then we kind of move forward from there.
Yeah, I thought it was a great looking building. It was very pretty. The second part to my question, so I know as a structural engineer, much of what I coordinate on is trying to make the architectural focal point a reality. And so I saw in some of the pictures that there's some pretty large overhangs on this building. And I'm wondering, was there much back and forth between the structural and architecture team to be able to have that overhang, but also make it a realistic overhang? Either architecture or structure, if you have any input. No coordination?
Casey, who do you think should answer this question? Let's call out somebody.
I was thinking Jonathan, but I don't know. You up for it, dude?
Sure. So yeah, being honest, I don't think we really had any coordination with that.
That's okay. I guess that's the answer. That was it for me. Great presentation, guys. I really enjoyed it, and yeah, great job.
Yes, I kudos. I mean, the graphics were fantastic, very clear, very well done, and very thorough. I thought you did do a lot. Jonathan, don't sweat it. I think you guys did a good job at coordinating, and it's very clear that you guys did. And honestly, the design is extremely complex, so you guys really took on a bear of a project.
We just need the contractor to get things built so we can have the presentations in the auditorium there. So I have a few comments or questions. I guess part of it on the roof was answered when you said you were going to have sidewalks with rails on them, but how are you going to was there an intention or an opportunity for barrier-free access for the roof? Because I'm sure that there are people that would love to be able to take and get access to that roof that are unfortunately challenged.
I think I can take this. I think with the layout of our roof, because we have the kind of three sections, the two on either side of that are above the like circle of solar of the skylights, and then there's that one that's right in the middle at the front of the building. Because of the layout, and then we have our solar panels that are in those different parts of the building, I think it would be hard to have public access to those. To like, I mean, you could probably have like a bordering wall between like walk spaces and solar panels, but I think that would be hard to do, have logistics. I think we would definitely have though some, not necessarily public access, but access for like restaurant employees for the garden, because obviously that's there for them. So I think the green roof and like garden was meant for the restaurant, and then the plants, and I think that we just kind of meant that to be kind of enjoyed from afar from the walkways that are on the roof.
Okay. The structure is built close to the Puget Sound, which is saltwater. When you were looking at materials for the building, did you consider the corrosive aspects of the site? And that would be, I'm hoping the structural and the architect, whoever did the building envelope, would be able to answer or work on that question.
I could partly answer that. Can you see me, actually? Yep. Wonderful. Well, for structural engineering, we did go a lot about the different materials and different ways we could put beams under the building. And so we were fortunate that our location was actually fairly strong. I believe it was clay, if I'm not mistaken, mostly clay. And we worked really hard on it. And we were really fortunate to have a really strong foundation. It wasn't too close to the water where it was insecure. So, yeah. Yeah. So anything to add, Jonathan?
Let's see. So a large part was that it was that the ground it was on was pretty solid, and that it still was, I'm pretty sure it was still above the water table, so that it would generally not have too much contact with the water. I think that's pretty much it.
Okay. And only because I'm a mechanical engineer, and we got to make sure that the mechanical and electrical students get to have a little bit to say. Having worked on a project, our firm did the Experience Music project, which is there's not a flat roof on that building. How did you guys figure out how to get the ductwork? And I know the question came up earlier about the air handling units, but ductwork and all the equipment to fit into those spaces, because you don't really have a lot of straight roof lines to work with. Did we lose our mechanical and electrical?
Who's on that team, Casey? Any ideas?
Is it Lucas?
I thought it was Lucas.
Well, that's okay. We can move on. I think you guys did a great job. And you know, hopefully you'll stick around at the very end. I have another little piece to add, but I think the presentation went very well. It's very well organized. I really do like the graphics that you guys did put together and the modeling that you did. Outstanding job. Thank you.
There are a couple of questions in the Q&A box I think I'll throw out. the building has such a large space, what kind of considerations was given for expansion joints? I think that's a structural question, right? Is that what that is? Okay, so Andre or Jonathan, you guys are structural, yeah? Maybe that's a tricky one. Okay, what about rainwater? For LEED certification, did you need to evaluate rainwater and what to do with all the rain that would fall on the structure?
So for when we were going through the LEED certification, we definitely did talk about the rainwater, and because we have such a big roof space, we didn't show this in our model, but we had ideas to have kind of like cisterns kind of located at either like point in front of the building to collect water as it kind of converges at those ends of the building, as far as where we would collect the rainwater. And so, yeah.
Okay, thank you. Last question, how do you plan to make the stage visible to everyone without tiered seating? So is that an architect interior kind of question?
I can get this one. So this was a concern that we actually brought up a couple times throughout the design of it, and we realized that we did have some limitations in terms of space and whether we could go up or down or out. So what we tried to do is we tried to make it tried to make the seats on enough of a slope so that if you're in the back, you're not staring directly at the person in front of you. So there's like the floor is at a little bit of a slope, but not too much to the point where it would be dangerous. And we also tried to keep the auditorium relatively small so that we didn't have to go at too much of an angle or even be forced to, do tiered seating. So it was just kind of, we had to incorporate some little things all throughout to try to make sure that everybody can see the stage and everybody has a good experience overall.
Okay, nice job. I did get one more structural question. Did you calculate earthquake loads and how did you design to work against earthquakes? So who's on our structural team?
I'll take this one. So we really didn't have really time to calculate for earthquakes, but we tried to make sure that we were significantly over what we needed to support the building, and kind of just hope that would be enough, because we ended up kind of running out of time, so we couldn't calculate earthquakes. So
yes, that happened to quite a few teams. I think changing to virtual was kind of wild. So you did a great job with the time you had and the method of communication. So great work. I thought I'd let the judges, if you want to say one final conclusion or a word of advice or something, and then we'll move on to the second team. Anything to add, or are you good? Okay, Larry's good.
Oh, I'd like to add something.
Oh, Andre, please.
Hi. Well, my name's Andre Henthorn. I'm a senior at Roosevelt High School, and I just wanted to say that this was an amazing project to work on, and definitely for my last year, this was definitely a beautiful project to work on and learn more on, and that all of us, I can tell that all of us had a great time working on this project, and it was fun, and we put a lot of time and effort in it. So thank you everyone for being an ace and having us work together. It was definitely a privilege this year to work with everyone. Thank you.
All right, thank you. Thank you. Todd, did you want to say anything, or we can move on to Wednesday team 2?
We move on. I think that was a really good closing statement, so I don't want to ruin it.
Fantastic. Good. The students are who I want to hear from anyway, right? Okay, before we get started on Wednesday 2, I am going to go into the participants list. I'm going to turn all of the Wednesday 1 students into attendees, and Mark, my co-host, is going to turn all of the Wednesday 2 students into panelists. So it's going to happen quickly. You'll notice it's just a quick little transition. And I'm on it. So just imagine we're all on stage and everything is moving. We're all moving around. See, it's just like real life, except it's not even close to real life. Oops. Dang it. We're almost there. Okay, almost there. Just go through the attendees list and see how we've done. Okay. All right, I feel good about that. If we missed you, send me a message. All right, and let me introduce our Wednesday Seattle Team 2 team leader. Mark, you can change the slide so we can show his face. This is Dan Schwab. Dan Schwab at Methuen. I know that you have an intro in your presentation. Do you have anything to say, Dan, or should we just let it roll?
Of course I have something to say. When don't I? Yeah, we'll just let my presentation say it, although I do want to thank ACE for another great year and the guidance to continue the program during the quarantine and giving us the support we need to continue and have it be a successful program. So thanks to everybody, and my great ACE students. Have a great summer, and hope you can get out and see your friends and do some fun stuff. And thanks to all the mentors for sticking with it. So anyway, great job, Wednesday Team 1. I just want to say that was a really inspired presentation and great project. So on to our great project.
Okay, let's let it roll.
All right, welcome to the final presentation of ACE Mentors Wednesday Team 2. My name is Dan Schwab, and I'm an architect with Methuen, and I'm the team leader for our ACE group this year. As you can see, we have quite a variety of mentor and student organizations represented here, a great group of people in our group. And I just wanted everybody to know how sorry I am that you weren't able to finish out ACE the way we had hoped. But hopefully everyone had a great year, and I'm really amazed and overjoyed at how well it came together in the end and how dedicated everyone's been to create this fantastic final presentation. It has been a strange year, but we made it through. I wish everybody the best for their summer, and I hope to see you all next year for hopefully a more normal ACE year. And now on with the show. This is Wednesday Team 2, The Wave.
Hi, my name is Emma Roller, and I'm a sophomore at Ingram High School. So our RFP, or request for proposal, had 3 options, and we ultimately decided on Site C, which is a waterfront amphitheater and performance hall across from the Seattle Aquarium. And because we left extra space on the site for things like pedestrian flow and artwork areas, we included a green roof open to the public, and we also considered sustainable options in our design and construction. We modified our site plan considering that the viaduct is no longer there and Alaskan Way will be shifted, and we also wanted easy access to and from Pike Place Market. And this is where our site is in relation to the waterfront and downtown. And as well as a 10,000 square foot performance hall and 5,000 square feet for supporting spaces like restrooms and concessions, we also included a small exterior amphitheater open to the public.
Hi, my name is Solly Span, and I'm a sophomore at Ingram High School. We did icebreaker activities to get to know each other, such as Ace Pictionary and building models with spaghetti and marshmallows. For our first design activity, we built coffee kiosks for Argosy cruises made from recycled shipping containers. The models were to scale of a site on Pier 56. We went outside to view our site for the final project to see what was around it and sketch designs accordingly.
Hi, I'm Zoe Clement, and I'm a sophomore at Ingram High School. When planning the exterior of the amphitheater, we went through magazines and online photos to find concept images that would incorporate the waterfront. Deciding on a wave concept, we found many pictures that we thought represented water. We also chose to have a slanted green roof on top of the building used as space for the public. When thinking about the interior, we wanted to continue our wave concept throughout the entire building. This is including modern and wave-like forms shown in tile patterns, the lobby, and in all aspects of the design.
Before we could start finalizing our floor plan, we had to create a project program to find information like what our estimated cost and square footage would be. We then went on to drawing up bubble diagrams to get a rough layout of our floor plan. The bubble diagram helped us look at features of the building, such as which spaces will have public or private access. It also allowed us to see the relationship between the rooms and how foot traffic would flow through them. Throughout all of our meetings, we used a 3D modeling software called SketchUp. SketchUp allowed us to mass various 3D designs for what the shape and exterior of the building would look like.
My name is Brant Sheldon, and I am a senior from Inglemoor High School. The site is located directly across the boardwalk from the Seattle Aquarium. It is fairly close to a variety of landmarks like the Seattle Art Museum and Central Library. The primary entrance to the building is directly across from the aquarium. The building is oriented to allow for maximum sun exposure on the green roof, while also protecting the green roof from winter winds. This orientation also allows foot traffic from both the waterfront and downtown to flow easily through the site.
I'm Henry Wiley. I go to Seattle Waldorf High School and I'm a freshman. For our floor plans, we were thinking of having storage and staff areas in the basement. And on the ground level, we would have a lobby with a stage and stairs going down. You can see the next slide. You see the side profile, and you see that the stairs actually are going underground, leading towards the stage. And we ended up actually not having the top seating portion, but we still included the other sections.
Hi, my name is Elise Soper, and I'm a sophomore at Shorewood High School. So after establishing the basic design, we went on to modeling our building in SketchUp. Here we were able to refine the shape of our building to better fit the space, as well as test out different facade ideas. Moving on to the interior of our building, this was also rendered in SketchUp, where we added inside amenities, acoustic panels, as well as other finishings. Since we couldn't work on the project together in person this year, we had at-home assignments, and here we practiced our sketching skills by drawing and labeling a nearby facade. When deciding on the facades for our building, we researched many types, including brick, glass, and metal. We then went through the process of narrowing them down based on functionality, design, and aesthetic. So something that's becoming more and more important these days is eco-friendliness, and we used the LEED scorecard to evaluate our design, where we reached our goal of achieving platinum status, which is the highest possible.
We eventually decided on brick and glass for our facades because the brick is cohesive with the other buildings in downtown and the glass adds a modern touch. And the north and south facades are brick with a layer of glass behind for stability and protection, and the glass curtain wall is on the west side facing the waterfront. To design the brick facades, we used a computer program called Grasshopper, which reads the contrast and the reference image and mimics the design by rotating the bricks. Because the bricks are rotated, the facade looks slightly different from various angles. And here's our design from a bird's eye view.
My name is Mati Sriram and I'm from North Creek High School. The site program was centered around the green roof functioning as a public park space with a hammock space as a relaxing or social area, along with a view deck, ADA access, and an amphitheater, as well as a connection to the bridge to Pike Place Market. These are a few of program precedent photos, which were inspiration for the hammocks and the amphitheater.
The site at ground level is designed to allow rest for pedestrians while preserving foot traffic flow. It also contains stormwater treatment along the southern side of the building. The entry lighting is designed to contribute to a relaxing ambiance. The green roof is a public park and designed to be ADA accessible up to the lowest deck area. The roof will have a mix of intensive and extensive green spaces, and mechanical equipment will be housed under 2 of the wooden view decks. The planting pellet is designed to withstand the extreme heat, sun, and wind conditions of the roof. The plants in the bottom left will be used in stormwater treatment on site. Trees will also be placed throughout the lower green roof and under the overhang to provide shade and habitat. This is a perspective view from the south side of the site. The black shapes on the lower deck area represent the hammocks that were shown in an earlier precedent image, which are part of a relaxation area. This is a view from across the boardwalk, showing the bike parking and movable seating on the ground level. The lighting concept shown earlier will be suspended from the roof overhang.
The stormwater is treated through a series of terraced planters along the side of the roof. The plants in the planters are the slough sedge and shore sedge. The small amphitheater is located on the green roof, providing a turf seating area for comfort. It is cut off a few feet from the edge for a caution, with planting essentially spilling over the edge of the amphitheater. This is a SketchUp model which shows the cutoff from the edge as well as the spilling plants.
My name is Jasmine. I'm a junior at Inglemoor High School. So structural engineers designed the structure of the building, and just like the structure of the building is like the skeleton of your body as it gives form. And we make the project become a reality by helping the architect's design come to life while making sure the building can support its weight and other forces that will act on it. We also have to decide what are the best materials to use for our building, while also considering the strength and durability to ensure that it is a safe structure. A load is any force or stress that is placed on the structure, which comprises of 2 main categories of gravity loading and lateral loading. And we need a load path to analyze how the load passes through the structure and to the foundation. And as you can see in our building, the load is placed onto the roof beam, which then transfers to the roof truss, and then to the column, and then to the foundation. Gravity loads are vertical forces that act on a structure, which includes dead load, which is permanent weight on a structure, and also live load, which are forces that can be moved through the building. So we created a load table to figure out how much load in pounds per square feet will be placed on our building among the different load types. And as you can see, one of the load types we came up with is stage, and we calculated 150 pounds per square feet of live load and dead load, and we used the American Society of Civil Engineers book to determine the different amount of loads we should calculate in our building. Lateral loads or horizontal loads on a building from earthquakes and wind,
And these forces tend to make our building want to bend along the direction of the forces. And as you can see in the bottom right picture, the wind is coming in from the right, which makes our building want to deflect to the right. So we used a brace frame to provide stability and support to our building.
Hi, my name is Bellamy and I'm a junior from Inglemoor High School. For the structural systems in this building, we created a steel structure with concrete flooring. This means that the beams, columns, braces, and trusses are all steel, while the slab flooring is the only concrete element. The majority of the building is a frame structure. However, we also use a long span system in the roof. This uses tension and compression elements to hold the building together without the use of columns. It's important that we avoid the use of columns in the middle of this building to keep a clear view of the stage. To build the long span system in the roof, we use trusses. A truss is just an assembly of beams that moves together as one object. The shape of the truss allows for flexibility so it can bear the tension and compression by adjusting its shape. In the blue diagram, you can see the compression on the bottom of the truss, while the top is stretched out. This allows it to bear the weight of the green roof without collapsing. In our actual design of the trusses, we use W12 by 190 steel beams for the chords, which are the top and bottom horizontal beams. We use 2L8 by 8 by 3/4 steel beams for the vertical and diagonal beams. You can see this in the top diagram, which is multicolored. For the floor framing, we used steel structural supports, then covered those in concrete slabs. In the model to the top right, you can see the beam, which is the horizontal support, and the girder, which is the vertical part of that support. Then, stud connectors connect the sheeting, which is the wavy part, to the beams, and concrete is poured in place over those. We designed the bays, or areas, that are covered in this flooring in Skipper, a simplified structural design tool used to find the most efficient way to build the framing. Finally, throughout our wavy exterior walls and tall interior spaces, there are many columns used in the building. Columns are simply elements in the structure that transfer loads vertically. In this building, the columns transfer loads from the roof trusses, beams, and girders to the foundation. Columns have interesting behaviors that must be accounted for when designing heavy buildings like this one. The load on a column is usually an axial compression, which means it runs down through the column, pushing on it downwards from the top. However, when this load gets too heavy, a column can buckle. This is where a part of the column will suddenly spring to the side when it is overloaded. To avoid this, we used very large columns throughout the building so it could support the weight. When it is possible to keep the columns hidden, we used wide-flanged or eye-shaped columns. However, when they are visible, we used round columns as they are more appealing to the eye.
Foundations transfer load from the structure to the ground. It is the last part in the structure's load path. And the ground conditions at our site is by the waterfront, so there's a high water table because we're close to the water. And there's also poor soil conditions because the ground is made up of fill, which is leftover material like soil and trash in the waterfront area. Our site is also prone to earthquakes, so liquefaction will occur during earthquakes. Therefore, we decided to come up with a deep foundation system. So deep foundation system transfer loads deeper into the ground where the soil layer is stronger, and it is made up of steel piles, which are H-shaped steel elements driven into the ground. This anchors the structure during uplift and prevents our structure from floating.
Hi, I am Ethan Deep. I am from Inglemoor and I'm a freshman. MEP stands for Mechanical, Electrical, and Plumbing. They are essential to a building's functions. Although it may be behind the walls, it helps to maintain the building's life and keeps people comfortable. HVAC stands for Heating, Ventilation, and Air Conditioning. HVAC systems function to maintain the comfort and safety of building occupants. Heating and air conditioning components assist us by controlling indoor climate and proper airflow, ensuring that we don't freeze or sweat.
Throughout our building, we use variable refrigerant flows, VRFs, to heat and cool smaller rooms. VRF systems are really great at simultaneously heating and cooling different rooms at the same time, as well as equally just redistributing any wasted energy from other rooms. For our larger spaces, we use DOAS systems, dedicated outside air systems, which are typically designed to be used for larger systems. DOAS systems take outgoing air and use that to initially heat the incoming air, and then use supplementary heat such as gas, electrical heat, heat pumps, and other systems to finish the heating. This is a diagram of our VRF system and its distribution. Starting at our 240,000 BTUs per hour outdoor units that each go to a manifold and distribute to different indoor units with different capacities. This is a one-line diagram of our electrical system. Our electrical system mostly gets its power from Seattle City Light, but also has photovoltaics to add a little bit of supplementary power. Our electrical system also has a place for touring shows to connect any additional equipment they may need. Throughout our building, we decided to use stormwater, to reuse stormwater for non-potable uses such as flushing toilets, and high efficiency appliances and fixtures to make the most of the water we had.
My name is Leona, and I am a junior at Ingram High School. This is our site logistics plan. It is the safest plan we think possible for this site and the least disruptive to the public and adjacent buildings and businesses. The location is tough because we're blocked by the waterfront on one side and there's less access than other sites might have. We're also close to the water table, so digging will be a challenge. Our site is downtown in a very popular area with lots of people and traffic, but we have included many ways to keep the public safe. These include covered walkways, site fences, and traffic control staff, and we will also require our staff to wear the appropriate PPE, such as hard hats, boots, gloves, face masks, and glasses. We will have to have various lane and sidewalk closures throughout construction to make deliveries and pick up waste material. To minimize the impact of these closures, we will schedule them with the deliveries and pickups. Moving on to the space, our building takes up most of the site, so our laydown area is pretty small, roughly 50 by 20 feet, but we may be able to use more of the site at times throughout construction. We will also be scheduling deliveries and pickups with when the materials are needed to maximize the efficiency of our laydown area. We may need to rent additional space, though, such as a nearby parking lot. We will also need space for staff offices and parking. For the offices, we might need to bring in a trailer to the site, or we might just rent office space in a nearby building. We don't think that parking will be a problem because there should be ample parking available in downtown Seattle. Lastly, we have decided to use a crawler or mobile crane. We don't think that we will need a tower crane because the building is pretty low, and a crawler or mobile crane is more cost effective and appropriate for this project.
My name is Callie, and I'm a sophomore at Shorewood High School. This is the overall detailed schedule that we put together for our project. This schedule identifies 5 key elements that go into a schedule: the task name, where it lists the broader categories of tasks, and then the specific individual tasks within each category. Next is the start date, end date, and duration, which is the specific duration for each task. After that, you can see the quarterly schedule, where you see how long a task is relative to other tasks and where tasks can be done in tandem. You can also see the specific order of tasks that need to be completed. Our 2 biggest dates are mobilization to site, which would be May 3rd of 2021 and is the beginning of construction, and final inspections, which would be October 16th of 2023, and is the end of construction where we receive final sign-off from the City of Seattle. Overall, this project will last about 33 months from the start of design to the end of construction. The schedule is split up into 6 main groupings once we have mobilized and taken over the site. Mass excavation, shoring, and utilities, which last about 7 months from May 25th of 2021 through March 28th of 2022. This includes demolition and, of course, excavation, which is made more complicated due to the fact that we will be digging 20 feet below grade, and at 10 feet below grade, we hit the water table, meaning we will be working under the water table, so we will have to do a lot of dewatering to get us out of the ground. Shoring is also a very important piece because we need to make a bathtub for the building to sit in so the water does not leak into the building from the water table. Structure is next and will last about 7 months from September 28th, 2021 through August 22nd of 2022. This slightly overlaps with the mass excavation phase. After that is enclosure, which will last about 5 months, and interior, which will last about 4 months. After that is special construction, which will also last about 4 months, from January 10th of 2023 through June 26th of 2023. This includes the fully occupiable green roof. Lastly is site improvements, which will last about 1 month from January 10th of 2023 through February 20th of 2023. This includes light poles, benches, and installation of trash can receptacles and bike racks. On the right-hand side of the screen, we have a detailed estimate that includes the total cost for each scope and the cost per square foot of each item. At the bottom, you can see that our total construction cost is $46 million. One of the biggest cost items is the subgrade construction due to the presence of water and the need for a dewatering system because of the site location. Another item is the green roof because it is occupiable. Lastly is the interior, which comes with great significant cost because of lighting and acoustics requirements. Despite the fact that this project has a smaller square footage than most Seattle projects, there is a higher cost per square footage because of the higher end furnishes and increased labor costs that come with this type of construction. Other costs are the design cost, which is $1.8 million, permitting, which is $1 million, and includes site utilities, right-of-way, shoring, and overall building and special trades permitting. These need to be submitted at the beginning of the project so that the city can review them, which takes a long time and could increase costs and push back the project if it runs too long. We're also carrying a 3% construction contingency, which is about $1.2 million because of complexities that we found in the design that will make construction a bit difficult. This will help us with unforeseen conditions throughout the project. The subtotal direct cost ends up coming to about $41 million.
Okay, thank you very much, Wednesday Team 2, for your presentation. I liked the building a lot. I liked it a lot. It reminded me of the Olympic Sculpture Park Pavilion. I would like to invite the panelists to ask a couple of questions. So Beatrice, Larry, Todd.
Maybe go backwards this time. Larry, you want to start?
All right.
I will start because there is a mechanical question in the Q&A chat room. With using VRF, where did you plan to locate the VRF condensing units that will serve your VRF fan coils?
I got this one. For our VRF condensing units, we plan to locate them underneath one of the designated decks up on top of the roof, along with our DOAS unit.
Okay. When you were designing the theater space, that usually has a high occupancy load, and which encumbers a latent load, which is a moisture that the people give off. Did you consider that when you were doing your HVAC design, and how were you going to treat that or handle that?
For latent load, we didn't have the time to fully go into calculations, but how we dealt with it was we added some extra room for error on either side so that we can make up for any latent heat.
Okay. And then sticking to the theater space again, how were you planning on doing the supply and the return air for it? What was your intent?
For the supply and return air, we were planning on having small ducts and fans placed periodically throughout the roof, along with the sound plating.
Okay. So what I'm really interested in is in the actual performing space. Where were you going to have the supply air blow onto the patrons, and then where was the exhaust or the return? Because it's pretty high space. That's why I'm asking the question.
Yeah, we were likely going to put it mostly blowing down on the audience, as well as collecting down maybe towards the lower end.
And then only because we got to give the electrical a chance to talk. Hopefully that's a different person. For your lighting schemes for the building, what were you considering? Because we're a LEED Platinum building, there's got to be some specific lighting that you were considering for the space.
Unfortunately, it is not a separate person.
Okay, that's okay.
But for the lighting, we tried to find as energy efficient lighting fixtures as possible, as well as just trying to keep them as dim as possible whenever possible.
Great. That's all for me for now.
I have a couple questions. First off, great presentation again, very thorough. I really enjoyed it, and great looking building. So I noticed at the beginning of the presentation, there are some renderings with these V-shaped columns at the front of the building. And I was wondering if, and then later on, the renderings just became straight columns. And I was just wondering if someone could speak to the design process and why you guys veered away from those V-shaped columns. Someone from architecture?
Probably a good question for Elise or Emma.
Yeah, I can take that one. So I think the column design, yeah, we started out using V-shaped columns, and then that was kind of just initially to get the column, to get an idea of what it was going to look like. And then as we started refining the design, I think we chose the straight columns just to give it kind of a more cleaner look. I don't think there was too much thought that went into the columns. We just overall decided we liked the straight columns better than the V-shaped ones.
Perfectly fine reason. I mean, cool. I had another question, and this is kind of both for architecture and structural. So I was wondering what the inspiration for the sloping roof was, and if that then, did you guys first decide to slope, and then that required you to go below grade as opposed to just building up? And was there any coordination between structural and architecture to decide to go below grade?
I can answer this one. So with our initial, when we started brainstorming, we were looking at like wave concepts and different wave ideas to incorporate the waterfront. So in our initial designs, we had a wave shape for the roof, but then different groups had different ideas. So one of the smaller groups had theirs going underground, and we liked that idea considering there was public access on top of the roof, so we didn't want it to be too tall.
Great, that's all from me. Todd, do you have any questions?
Oh yeah. Hey, just overall, really great presentation. I really thought the process that was illustrated throughout the entire presentation was very clear. And as an architect, I've never really been so engaged in listening to a construction schedule and cost estimating before in my entire career. So thanks for that. It was really, that was really educational and quite frankly, very clear as to why you came about in the price. A couple of questions. You know, you had, the team had stated that it was a LEED Platinum project. And one thing I missed was I saw a few sustainable practices, particularly with a green roof. There were some plumbing fixtures that I believe that were, you know, automatic and what have you. And then I think you just talked about lighting. was there any other general strategies for sustainability that you had thought about or decided on that weren't in the presentation?
I know for HVAC, a part of our discussion was trying to figure out what type of ventilation would be the most efficient for energy consumption, which is partially why we chose DOAS units, which recycle some of the energy as well.
Great. How about on the landscape or architectural side too?
I can answer that. From the landscape perspective, we did consider solar panels or some sort of solar array. We did orient the green roof to allow for that, but we decided to just make it into a public park and not detract from, you know, the nature feeling there.
Great. There is an additional question on the list, and it's I'm wondering what consideration there was for mass transportation and parking nearby. With the viaduct going away, how do you move traffic in and out? And I'm assuming they're referring to just specifically the site. It is a pretty confined site. I don't know if anyone can answer that question. It is a pretty tough question.
Elise, do you have some thought about the parking? Maybe talk about the garage next door or the new waterfront roadway.
Yeah, so with the parking, I think I didn't really work too much on that, but I do remember we did talk about doing parking nearby just because the site was so limited. We didn't have that much space to put parking, but I'm not quite sure what the plan was for mass transportation. I think that might be more contracting.
Good answer. That's it for me. Nice work, everyone.
Okay. Did the judges have any final thoughts that they wanted to share? Anything left? Anything else? Give you one more shot.
Go ahead, Todd.
Oh, no, I'm good. Thank you.
Okay.
Well, I would say that the presentation was very well done. Again, both groups did a great job. One of the things that I would commend all of the students, even that started out on day one, Monday, which I was at the first presentation. You should all be proud of yourselves because of the situation we're in. You started something and you finished it. And not a lot of people can say that. And especially in the generations that you are in, there's a lot of people there's a lot of ghosting that goes on. They start something or say they're going to do something and they're not committed. You guys were all committed. And make sure that you let people know that in the future, because we won't have another 2020, hopefully. But when you go to job interviews in the future, use this as an example of how committed you really are, because you did start something and finish, and you should be proud of that. And I'm proud of all of you for doing that.
Thanks, Larry. There were some ACE teams who had 90% of their students retained throughout the year. They didn't lose anyone after COVID started. There are other ACE teams that lost quite a few. So yeah, it is really something special to say for the ACE group this year. Well, the designs were fantastic, very impressive. Every year, this event and the innovation that the students bring to the table is inspiring. So there's no doubt that the future of the built environment is in really good hands. So you should feel amazing tonight. Congratulations. Just one last thing, while there are many mentoring programs designed to give high school students exposure to architecture and engineering, ACE is unique in that it exposes students to the breadth of the entire building industry while providing this hands-on experience through a design project. Putting together this program takes a tremendous amount of time and energy and dedication. In fact, we've compiled the numbers and we've learned that we run a $1 million program every year. But while the lion's share of our program is pulled together by mentor volunteers, donated corporate time, donated meeting space, we do incur a few costs as an organization. We don't need to raise $1 million to put on ACE. We figured that it costs about $235 for each student, but we're able to offer this for free, the program for free through our corporate donors and other individual sponsors. So if you and your student had a great time this year and you feel inspired and you'd like to make a donation, everything that comes to ACE is tax deductible. We are a 501c3 organization. We are happy to offer this program for free to the students in the Puget Sound area, and we will continue to do that for years and years to come. So a donation page is in the program that was emailed out earlier today, if you feel so inclined. But congratulations to all of the teams. I want to give one last special thank you to Mark Kinsman at Mortensen. He was our technological guru all year long, or all week long. He did the webinars for us this week, and it's gone really well because a lot of his coordination. So thank you, Mark. He's our angel. Okay, well, that's it for me. Thank you for coming, and we'll see you next year.